0. Okay, and its shape will be a straight line. Okay, so which is this line which is drawn in this blue color? This one. This one is the line, or this one is the signal whose frequency is 0, and what is its amplitude? Amplitude equal to 15. Okay, so that's why this first line is represented or done here. Okay, at 0 में एक spike हुआ है जिसका value 15 तक है. Look at the pink line or red line. Okay, so that is completing how much? 8 cycle you can count. 1, 2, 3, 4, 5, 6, 7, 8. 8 cycle or 8 hertz it is. Okay, so that means I have one 8 hertz signal. Okay, so that's why its frequency domain is equal to, is looking like this. Okay, or in frequency domain representation, it is looking like a spike existing at 8. Similarly, the green one is completing 16 number of times. Okay, or it is flipping, or it is revolving, it is making 16 cycles in 1 second, or it is 16 hertz. So that's why at 16 I have one line. Okay, and what is the amplitude at for the green one? Amplitude is here, you can say 5. Okay, and at 10 this pink color, that amplitude is 10. Amplitude is 10. Okay. Okay, so actually this figure is given for your understanding only. Okay, nowhere I mean this actual signal will not look like this. Okay, so let us say you have 3 sources of signal. This is creating this blue line, and another source of signal which is creating this pink. Okay, plus another source of signal which is creating this green. Okay, so when they will be combined, the signal will be, I mean, something like this. Okay, it will be looking like this. So this signal is having, let's say, these 3 components. Okay, so this signal is having these 3 components. Okay, and that is represented in frequency domain using this figure, using this figure P. Okay, we'll see the next figure so that it will more. Okay. Okay, anyway. So till this point, have you understood?
Sir, how blue line signal have amplitude 15? I didn't get it.
Okay. So let us say this point is 15. Okay, so I had a signal like this, not like this. Okay, let us say one signal was like this. Okay, so this value is, let's say, 15. Okay, so here the amplitude is 15. Okay, so now let us say this signal is not its frequency is increased. Okay, if this frequency will be increased, take another color. Now let us say it is 1 hertz. Okay, ये जो ग्रीन सिग्नल है उसका एम्पलीट्यूड कितना होगा? 15 होगा? Yes or no?
Yes.
Okay, but still its frequency is decreased. Now let us say I'll take that same signal. Actually it is, there is no space to draw. Okay, like this. Okay, it is very slowly decreasing. Okay, is a sinusoid मतलब जो it is getting increased decrease जो हो रहा है. Okay, so that is happening with a very less rate. Still the blue signal will have the frequency is very low, but its amplitude is 15. Okay, now let us say the same thing I will draw with another okay, this orange color, let's say. Okay, actually it is completely straight. Okay, it is not decreasing. Okay, so in this case, what you will say, its amplitude is equal to how much?
15, sir.
15. And
15.
its frequency is how much?
Zero.
Frequency 0.
0. Understood? Means initially, let us say we had a actual 15 actual signal, okay, so which was having some finite frequency, but gradually the frequency is decreasing. Okay, so when it is decreasing, the curve is not getting changed. At last the curve is getting a straight line. Okay, so that's why that
सर मीन्स मतलब हम लोग कह सकते हैं कि वो तो जीरो होगा नहीं, लेकिन वो टेंड करेगा जीरो तक ना। फ्रीक्वेंसी एग्जैक्टली तो जीरो नहीं हो सकता है ना सर, टेंड तो करेगा जीरो तक।
नहीं हो सकता है। क्यों? सपोज if some signal is getting changed, then it's have a frequency. Suppose I'll say the temperature of this room is constant at 15, it is not changing ever, always it is maintained at 15. So in that case, the signal frequency will be equal to how much? Its frequency equal to 0. If this frequency or temperature is getting changed, then the curve is getting up and down. If the temperature is constant, then obviously the line will be also constant. Yes or no?
मैं क्या बोल रहा हूँ कि अगर वो स्ट्रेट लाइन हो जाएगा तो उसका ऑब्वियसली एम्पलीट्यूड जीरो हो जाएगा ना,
क्यों?
क्योंकि वो ओरिजिन से खींचा हुआ लाइन रहेगा।
नहीं, ओरिजिन से देखो, सपोज तुम 0 से स्टार्ट करके जा रहे हो, ओके, सो इंस्टेड ऑफ दैट its amplitude is already, let's say, 15. Okay, if I mean, if it is 0 and from 0 it is not improving, okay, if it is at constant at 0, then you can say its amplitude equal to 0 as well as frequency equal to 0. But I am telling you, okay, just if I'll draw like this, okay, so this is one curve. Okay, so this is one signal, let's say. Okay, so here the frequency is 0 as well as the amplitude is 0. Okay, if I'll draw like this, okay, that means its frequency is 0 but amplitude is 15. That means its value has been fixed at 15.
ओके
Okay.
सर, ओके, आई गॉट।
सर बट एम्पलीट्यूड तो जितना हाइट क्रेस्ट ऊपर उठता है वो होता है ना एम्पलीट्यूड सर।
Yes.
तो इस पे तो सर इस पे तो अगर कोई मूवमेंट होगा ही नहीं, जैसे नीचे वाला किए हैं तो एकदम स्ट्रेट लाइन है, उसपे तो मतलब उसका क्रेस्ट नहीं है, ट्रफ नहीं है, तो उसका हाइट कैसे मापेंगे? 15 उसका हाइट कैसे होगा? 15 हाइट तो सर वो
देखो, with respect to 0 we are checking. Okay, so when you are doing the amplitude, you are not finding out the difference between the peak and the crest. You are measuring with respect to 0 how much it is up. Okay.
ओके सर एक तो अगर 15 सेकंड वाला जैसे स्ट्रेट लाइन बना है और एक वैसे बनाइए जिसमें सर वो उसमें होगा ऐसे साइनसॉइडल वेव होगा, तो बनाइए नीचे सर।
I'll draw a sinusoidal wave, right?
At 15 degree from the 0.
Okay.
Yes, sir. So what is the amplitude here, sir?
Amplitude
Provided where the point where the graph was started, it is not 0.
Okay, this is not 0. This is what?
सर आप जैसे सेकंड वाला बनाया ना सर, सेकंड वाला में जो ग्राफ स्ट्रेट लाइन तो है, वो स्ट्रेट लाइन नहीं होके उस पे होगा फ्रीक्वेंसी होगा।
Okay, so what you are saying, actually this point is 0. Okay, so if this point is I'm not getting question, then what I have to do?
राइट सर, यही करेक्ट है सर, दिस इज करेक्ट।
No, what you are asking, this figure I have drawn, then what I'll do?
नाउ द एम्पलीट्यूड इज 15 ना सर।
Yes, this amplitude is 15.
हाँ तो फिर if the amplitude of the third figure is 15 because there is a we measure from the point of origin, from that is 0.
Yes, right.
And in the second figure when there is no crested trough, so how will we measure the amplitude? The graph itself.
Yes, with respect to 0 you are measuring. Okay, with respect to 0 you are measuring.
Right sir, because the definition of amplitude is the highest point in the frequency graph. Right, correct sir, correct sir.
Okay, so if you go to the next figure, so as we saw in the previous figure, we have combined three different time domain signals, okay, which can be represented in the frequency domain. Okay, so now if you take any signal, if you combine them, then its shape will be different. Okay, and so let us say I'll take a sinusoidal wave.
Sir, I have a question.
Yes.
Sir, when we are using the two waves, then why they are not superimposing?
Yes, that thing I'm just explaining here. So you are saying that in the previous example, I mean 2-3 waves are there, so why it was not superimposed, right?
Yes, sir.
Yes. So here this was just, I told you that this is just given you for your demonstration for your purpose, for your understanding purpose. I mean, three different signals are drawn so that you can know I have three different frequency components are there. But actually, when the three frequency components will be added, then the superimpose will be happening, and the shape of the signal will be changed. So that just I'm drawing here. So let us say I have one sinusoidal wave like this, and the second one I have, it is having it is having 1 second, let's say 1 second, 1 second. So this is 1 hertz signal. I'll take one 3 hertz signal. That means it will complete 3 cycles in between this time. Okay. That will be one cycle. Actually, this shape was not drawn properly. So within this much of time period, I will have 3 cycles. Okay. So or you make it up 6 cycles. Okay. So now when they will be added up, okay. So when this, let's say this figure B, figure A, okay. So when figure B will be added up with figure A, so how the shape will be looking like? So you just make a line. Okay. So at this point, we have a crest. In the figure P, we have a negative thing, okay, which will try to decrease this value, okay. And similarly, this point is corresponding to this point. That means this will be going up and this will be going down, okay. So if I'll draw the resultant, what I will get, it will be somehow it will be like this. Yes or no? Because you see, this is one crest point, or this is one negative thing. Okay, so this negative will try to pull it down. Okay, or when this point value and this negative value will be added up, this resultant will be something less. Okay, and similarly, this is one positive, and here also it is some positive. Okay, so when they will be added up, at this point resultant value will be little high. Okay, so this will be the result I will get. That means when the 1 Hz signal and it is 3 Hz signal. Okay, when this is added, we are getting a shape like this. And in the negative cycle also the same thing will happen. Okay, so what basically the figure C is looking like? Is it looking little bit like a square wave? How a square wave is? Square wave means it is something completely like this. Okay,
Yes, sir.
this is one square wave. That means initially I have a pure sine wave. So when it is added with 3 Hz sine wave, this shape is changing towards a sinusoidal wave, towards a square wave. Okay, so with this result C, if you again add, if with the result C, if you add on, let's say another 5 Hz signal. I don't have space here to draw it or anything. Just you think, if you add a 5 Hz signal, whether this shape will be more like a square wave? Yes, that will be more like a sine wave. Okay, that means when the this 1 Hz signal and the 3 Hz signal. Okay, so this one is called as the third harmonic. Okay, third harmonic means what? It is the odd multipoles. Okay, the third harmonic or fifth harmonic or seventh harmonic, when they are added with the original signal, original sinusoidal wave, the signal will become like a square wave. Just look at this figure. Hey, who is unmuted? Please all of you mute yourself. Okay, so look at this figure. This is my pure of the let us say one sinusoidal wave with 1 Hz frequency. Okay, let us I will name it as A. This is figure P, which is the third harmonic. Okay, or which is having a frequency of 3 Hz. Let's say this one is 1 Hz. This is 3 Hz. Diptimoy, please mute yourself. Or I have to enter. Okay, so when figure A is added with figure B, you are getting the result, this one. This is the result which I saw in the last figure. Okay, here I saw new. Na? So when this 1 Hz signal is added with 3 Hz signal, we are getting a shape like little bit, which is little bit like a square wave. Okay, so when this figure C will be added with 5 Hz signal, let us say C plus D. Okay, so what result you are getting? Again, the signal is getting or becoming more like a more like a square wave. Okay, are you getting?
Yes, sir.
Yes, sir.
Okay, just it is very simple thing. I mean, when two different shape of signal will be added, then it will have different resultant shape. Okay, so initially I had a pure sinusoidal wave. Now it is added with a it's third harmonic. Okay, so when figure A is added with figure B, I got like a figure C, which is like a square wave. Again, this if the figure C is added with figure D, which is the fifth harmonic, okay, it will be becoming more like a square wave. Okay, next figure E, when it will be added with figure F, which is the 7th harmonic. Okay, so here we will be having more like a square root. Yeah, more like a square root. Like this, if you go on adding till infinite times, okay, at last we'll find out it will be completely a square wave. Okay, so basically square wave is nothing but it is the combination of different sine waves, which are the third harmonic, fifth harmonic, seventh harmonic, ninth harmonic. Like this it will go on, 11th, 13th, like this it will go on. And one more thing, when you improve or increase the harmonic, its amplitude should be decreased. Okay, so kya kiye hain, you just look at the figure A and figure B. Okay, when you are adding the third harmonic, we are adding with a 1/3 of amplitude. Okay, similarly, when this fifth harmonic is added, it is added with 1/5 of amplitude. If the original signal has an amplitude of A, it has an amplitude of A, then it has an amplitude of A by 3, and the fifth harmonic is having an amplitude of A by 5, and the seventh harmonic is having an amplitude of 1 by 7. Ninth harmonic is having an amplitude of 1 by 9. Like this, if you go on adding, so finally it will be a pure square wave. Okay, so ideally it is not possible to achieve one pure sine wave, because if you are talking about pure sine wave, okay, it should be having this infinite, or I mean very large number of this high frequency component. Okay, anyway, after addition of certain number of harmonics, it will be mostly like a sinusoidal, mostly like a square wave. Okay, so anyway, yes.
Sir, what if the figure A is directly added with the figure F or figure 9, means GH, H1? Means we are doing step by step. I just want to know, what if directly it is added with the figure having the amplitude 1 by 9?
Okay.
How will the figure look, sir?
Yes, that you can calculate. I mean, just draw and see. Okay, so if you just let us erase it. If you add this one or ninth harmonic with the first one, so what you will get? It will be like, okay, I'll draw it again. Not exactly like this. Okay, so this may be the shape. Why? Because you look at the ninth harmonic. Okay, ninth harmonic, how it is little bit up, little bit down. Okay, so if when that will be added with the original one, okay, when it will be superimposed, what will happen? At some point it will be plus, and some point it will be minus. Okay, plus minus, like this it will happen. Okay, I mean to some point it will enhance, and some point will be decreased.
Right, sir.
Okay. So that thing which I told you, that any any square wave is actually a combination of different sinusoidal wave, which are their third harmonic when original sinusoidal wave plus its third harmonic, fifth harmonic, seventh harmonic, like this. Okay. So to know what are the different frequency component available in a particular signal, we use Fourier transformation and Fourier series, etc. But that is actually more here we don't have scope to study about that, because we don't have time to read all these things. Okay, so that will be more clearly or completely taught to you in mathematics you have a complete chapter of Fourier series and Fourier transformation, and also it will be taught to you in different other subjects. So here just I will tell you, using that Fourier transformation, we can represent one sinusoidal wave using this expression. Okay, so here you see Vt is equal to 4V by pi sin omega 0 t plus 1/3 of sin omega 0 3t, 1/5 of sin omega 0 5t. Okay, it is already we have seen in that figure. What we are looking at, when we add the original sine wave with its third harmonic with amplitude 1 by 3 and plus with its fifth harmonic with amplitude 1 by 5. Okay, so here look at this expression. The sine omega 0 t is the pure sine wave plus sine 0 3t. That means what? It is the third harmonic. Okay, and what is its amplitude? 1 by 3. And sine omega 0 5t. That is what? It is the fifth harmonic. Okay, and its amplitude is equal to 1 by 5. Okay, so like this it is continuing. Okay, where this V is the amplitude of the square wave, omega you know it is equal to angular frequency. Okay, and if it is represented in the frequency domain, then it will look like this. You see, you have at omega 0, you have an amplitude of 4V by pi. Okay, and at 3 omega 0 or the third harmonic is present with an amplitude of 1/3 of 4V by pi. At fifth harmonic, it is present with a harmonic of 1/5 of 4V by pi. At seventh harmonic, it is present with a amplitude of 1 by 7 4V by pi. Okay, like this it will continue. That means if you have one square wave whose amplitude is V, okay, so it can be converted into different a combination of sinusoidal wave, sine wave, and what are the frequency and amplitude of those sine wave? Those are this. Okay, तो पहला वाला और जो प्योर साइन वेव उसका एम्पलीट्यूड होगा 4V by pi. Okay, next will be let's say 4V by pi into 1/3, next 4V by pi into 1/5. Like this it will go on decreasing. Okay, here we have seen that this is the first one is the pure sinusoidal wave. This is the pure sinusoidal wave. Okay, and next it's third harmonic with amplitude of 1/3, and then the fifth harmonic with amplitude of 1 by 5, then the seventh harmonic with amplitude of 1 by 7. Like this, we have different harmonic components. If you add them, then you will get a square wave. Okay, so that thing is just okay. So the last thing which we'll see, I think this is this table or these terms you must be knowing, but once more you should have just look at this thing, because sometimes during program calculation or any point of time you may be requiring it. Your millisecond, microsecond, I mean these are in the negative side or in the less than 1. Okay, milli is 10 to the minus 3, micro is 10 to the minus 6, nano is 10 to the minus 9, pico is 10 to the minus 12. And if you want to increase, I mean 10 to the plus power, kilo, mega, giga, tera. Okay, kilo is 10 to the 3, mega is 10 to the 6, giga is 10 to the 9, and tera is 10 to the 12. That means they are increasing at a distance of 1000. Okay, 1000 hertz equal to 1 kilohertz, 1000 kilohertz equal to 1 megahertz. 1000 megahertz equal to gigahertz, and 1000 gigahertz equal to 1 terahertz. Okay, so like this, here it is 1 by 1000. 1 by 1000 second equal to 1 millisecond. Okay. So till this point, we just have some brief idea about signal, what is frequency spectrum and the signal, and what is analog signal and digital signal. We saw about those things. So next point, we will be covering about this diode and its application. So basically, before starting this diode, we should understand what is semiconductor and why basically we go for this semiconductor. Okay. So till this point, are you clear? Before starting the second part, this signals part.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Sir.
So now, do we have any class? Yeah, it's a free time.
No, sir.
Free time, sir.
It's a free time. Okay. So what
Time, sir. No
I will
class.
not. Yeah.
There is no class, sir. It's free
Okay.
time.
Yeah. Please all of you mute. Okay. Right. So now I will not teach anything, but I'll just tell you why we are going for the semiconductor industry. Okay. Why we are studying about semiconductor? Why we are not? When you're talking about electronics, we mostly talk about semiconductor. Okay, we don't tell about, let's say, we are not taking a pure conductor, or we are not taking a pure insulator, but why all the devices or electronic circuit is created using semiconductor. Okay, right. So in electronics industry, let us say we are always talking about the processor. Okay, we have a mobile phone, inside that we have a processor. So we want to do some processing stuff over there. Processing means it will do a operation. Let us say I have 2 bits. I'll give you a very simple example. Obviously, these things are not done inside the processor. Okay, so let us say I have 2 bits. I want to do a ANDing operation. Okay, so I need a some sort of AND gate. So let us say I have A, B. I hope you must be knowing this thing, this truth table. So 0 0 0 1 1 0 1 1. Okay, so I want to do a AND operation. Okay, so my result should be what?
0 0 0 1.
0
0 0 0
0 1.
Yeah. I hope most all of you should be knowing this thing. Okay, so this is
अरे
the
बोर्ड
truth
वाले
table of the AND gate. Okay. So how I will implement this one in a circuit. Okay, basically there is one AND gate. I have one AND gate. You must have looked at its symbol. Okay, so this is the symbol of the AND gate. So you know that this is the symbol. That means if you give A, B 0 0, then I will get 0. If I give 0 1, then I will get 0. If I get both 1, then I will get a 1. Okay, so this much you know. Okay, but what is there inside a gate? How this gate is operating, or how this gate is doing this thing? Any idea? Anyone? Okay.
What are you
Transistor.
asking, sir? Once again.
Yeah, what is there inside this gate? How this gate is?
Transistor.
Transistor. Okay. So what is a transistor? Okay, transistor is basically a switch that we'll discuss. So I want to there are certain transistors are there inside this gate. So let us say I have this gate. So how this gate circuit looks like, just there that I'm doing. So this is actually not related to your this basic electronics theory or syllabus which you have, but you just have this for your interest. Okay. So let us say I have two type of switch. One is let's say positive switch, and another is negative. I will go to transistor later on. So let us say I have two type of positive switch. Okay, so this switch is having switch has how many terminal? Two terminal. But anything else? You have two terminals. One is input and another is output. And another is also thing that which you are pushing. The switch which you have in your house. Okay, it has an input side and another output side. Okay, and another thing is what which you are pushing. Okay, when you push it, then the switch will be on. If you are not pushing, then it will be off. So that is the operation of a switch. Okay, so like you have a switch here. Okay, so if it is pushed, then it will be connected. If it will not be pushed, then it will not be connected. Okay, so let us say this positive switch is designed such that if in physically the switch which you has, you are manually pushing with your hand. But the switch which will use inside the circuit, okay, so that will be not pushed by your hand. Okay, so that switch will be pushed by some electronic parameter like your voltage or current. Okay, so let us say I have one switch which is controlled by a particular voltage. So let us say this is one switch which is controlled by a voltage. Okay, so this is input side and this is output side. Okay, so if I'll give voltage here, then this switch will be on. Okay, and if I'll not give voltage here, then the switch will be off. Okay, similarly let us say I have one negative switch. Okay, so that means it is, let us say it is connected. Okay, this is input, this is output. Okay, not connected. Okay, so here if I'm giving positive voltage, then it will be connected, and in the negative type of switch, if I'll give some negative voltage, then it will be connected. Okay, so let us say I have these two type of switch. Okay, so to design this AND gate, what I'll do, I'll connect the switch like this. It may be looking a little bit complex, but actually it is not complex. So since I am giving you in a different way, or I am representing you in a different way, that's why it is looking like this. So this is my source VDD or power supply. This is my ground GND. Okay, and these are the positive switch. These are positive switch. This is positive switch. This is negative switch. This is a negative switch. Okay, so now if you are doing like look at the truth table. In truth table, what I have, if both are one, okay, if both the inputs are one at that time, my output should be one, and if anything will be like first case 0 0 or 0 1 or 1 0, okay, at that time the output should be 0. Okay, okay, or this is negative voltage or it's a 0. Okay, So if it is 0, then it will be on. Okay, just it will be opposite way. This is positive switch, this is a negative positive switch, this one is negative switch, this is negative switch. And here we are taking output Y. Okay. So here, if I am doing like if let us check the first case. If the input is 0, A is 0, B is 0. Okay, so this is for A, this is for B, and this is for A, this is for B. Okay, so in this case, A is given 0 and B is given 0. What will happen? So since it is a negative switch, okay, negative switch means what? It will be
Low current.
yeah. So it will be negative switch. Okay, so this will be connected or no? Sorry, I have written it positive right here. So that's why it's happening. Okay. So since I'm taking it's a positive switch. Okay, positive switch. If I'm giving 0 voltage, whether it will be on or off?
Up.
Off. Okay, so both are off. Okay, so if it is both are off at the time, what will happen to this? Okay, these are the negative switch. Okay, negative switch. I have given A equal to 0, B equal to 0. Okay, so look at here. The negative switch. If I'm giving negative voltage, or I mean comparing to the other one, it is 0. So at that time, it will be on. Okay, so this will be on. This will be on. So this will be equal to, or this point will be connected to ground. Okay. Similarly, if the other conditions also you can check and look at the last condition whether it is happening or not. If I'm giving both are 1 1, okay. So at that time, what will happen to this this switch? This switch will be off because it's a negative switch, and negative switch if it is given as 0, then it will be yeah, the negative switch if it will be given 1, then that will be off. Okay, so this will be off and this will be off. So this ground will not be connected, rather the upper side switch will be connected, and here the output will be equal to 1. Okay, anyway, so this is a different concept, or I mean you will read more about it in VLSI, but here my point what I want to explain is that I want to create one switch, not a physical switch which you are looking like in your electric switchboard. I want to have a switch. Okay, the switch will be controlled by electrical voltage or electrical current. That means I should have one type of device which can be controlled by applying some voltage. Okay, so if I apply this voltage here, then the flow of current will be happening, and if I'll not apply voltage, then the flow of current will not be happening. That means the property or electrical property or the conduction property of the material should be varying with the application of voltage. So how can I achieve that? So that is my question. Do you know any device whose property or whose connectivity can be controlled by applying electric voltage? Have you heard the name of relay? Relay.
Yes, sir, relay switch.
Okay, relay. What is relay? Relay is basically a magnetic kind of switch. Okay, that means inside that there is a magnet, electromagnet. Okay, so when you apply a voltage across it, it gets magnetized and it pulls the switch, or the it pulls another terminal which connect the electrical path. And when you disconnect the if you don't give voltage, then the magnet is demagnetized, and due to spring action the other side is disconnected. But that that relay circuit is a very big circuit, isn't it? Because if you see the relay inside your electrical devices, you'll see it's a at least 1 inch size or 2 inch size. But here we are talking about nanometer or micrometer. Okay, so how you cannot create the relay with such a smaller size. So we want any other electrical material whose property can be modified by the application of voltage. So that's why we talk about semiconductor. Why? Because the semiconductor is a material whose property or whose conductivity lies in between that of a conductor and an insulator. Conductor is purely conductor. Okay, its material property is such that it has high number of free electrons it can conduct. Similarly, insulator is its physical property is such that it does not allow current to flow. Okay, so that material cannot be also modified. Okay, but insulator is one type of material whose conductivity lies in between that of a conductor and an insulator. So its property can be modified by applying some electric field. Okay, so that's why we are talking about semiconductor. So if you have a semiconductor, by application of certain different things or certain different electric voltage or different other parameters, we can modify its property. Okay, so whenever we want it should conduct, accordingly we'll apply voltage. If we want it does not conduct, then we'll not apply voltage. Like this we have to do. Okay, so that's why the semiconductor has come into picture in our electronics industry. Okay, so we'll see more about it in the next class. So the example which I gave you regarding here, okay, it is it may not be very clear because once you will be studying about VLSI, all the other things, then you'll be knowing about how the circuit diagrams are actually drawn. There are different tools are there for that. Okay, but I just gave you for your understanding purpose only. The thing is we have to create a switch, and that switch can be created using semiconductor because its property can be modified by the application of electric field. Okay, we'll stop with this thing. Thank you. I'll take the attendance now.
Excuse me, sir.
Yes.
Sir, the negative voltage you applied on the last switch, the bottom to switch, that is the NAND gate, na sir?
Yes, I'm talking about the NAND. Yes, it will be actually NAND gate. Okay, so
that will be actually NAND gate, na sir?
Yes. After that, actually there will be inverter. Okay. So this thing is actually taught to you properly in your VLSI. Okay, so I can teach you about this thing now, but it will take some time. So that's why my point here was to show you that the switch is used. Okay, this type of switch. So these switch are nothing but these are the transistor. These are the
Hello,
transistor.
sir.
Yes.
Sir, Nisha Singh just now got disconnected and unable to come into the class, sir.
Why? Tell him to try again because
Sir, she is trying, but network issue, she is unable to. Just now she disconnected, sir.
Okay,
सर आज बहुत नेटवर्क इशू हो रहा, रिज्वाइन करने में प्रॉब्लम हो रहा.
Okay.
Sir, she just now disconnected, sir.
Okay. What is her name? Nisha Singh.
Nisha Singh, sir. Wait, sir, I'm asking.
Okay, you can end the meeting. What's her name? Anisha Singh, right?
Yes, sir.
Yes, sir.
Anisha Singh. Okay, I'll check. Okay. So now I'm ending the meeting. Okay, thank you all.
Thank you, sir.
Thank you, sir.
Sir, 42, sir, 42.
Sir, roll number 42.
Okay.